All right, so we're going to talk about transforming quadratics and writing quadratics in Vertex form after you've watched that brief little Desmos video. So what I want you to do is go to desmos.com. It's called Desmos. You can just start graphing. You don't have to have an account. I do, so it looks like I'm logged in here. And what's really cool about this is you can graph a line or a parabola or a cubic function or a sine function. You can do exponential functions. And you can type in y is equal to x squared. You can type f of x is equal to x squared. I'm just going to leave it with y is equal to x squared. And what I want to do is I want to show you Desmos has some cool features where you can adjust parts of the function and you can see what happens to them live. So what I want to do is I'm going to write this in Vertex form. And if you're not familiar, Vertex form is where you have something out in front of the parentheses, and then you have x minus something inside the parentheses, and then you have plus or maybe minus something outside the parentheses. And what we've done here is we've rewritten this red function now in what we're calling vertex form. This is standard form here. This right here, this blue function, is actually equivalent to the red function, and the reason I know that is because look at this. It graphed right on top of that red function there. If I click here to get rid of it, then it'll graph it. Oh, my wife's texting me. And so what we've got here is the ability to change these numbers and to observe how it affects the function. But it gets even better than that. You don't even have to go in and manually type in like, okay, how about let's try 2x minus 0 squared plus 0. Okay, you could do that and that would work. And you'll see here that the green function seems to be a little compressed sideways here. But what you can do that's really nice is instead of putting in numbers here, you can put in letters. So a x minus h squared plus k, that's the typical vertex form. And it gives you an option here to add a slider. And so if you come in and you press A, what it'll do is it will let you play around with certain values for A, and then we'll do it for H and K as well. And so what we've got now is we've got these sliders for A, H, and K. And I'm going to move them so that it's A first, then H, then K. Let's change it so that A is 1, okay, which it is. Let's make it so that H is 0, so it's the same as that 0. So let's make H 0. You can grab the slider or you can just go up and manually type it. And let's make K 0 as well, because that's what our original function was. And so you'll notice here this green function is exactly on top of the red function. And by the way, if you want to see a function or not see it, you can click this circle and it will either appear or go away depending on whether or not you have it clicked. Excuse me. All right, so we've got y is equal to a times x minus h squared plus k. And what you can do here, which is really nice, is you can play around with these values and it will change the function for you. So watch, I want you to watch over here. I'm going to change the value of a from 1 to 2 to 3 to 4 to 5 to 6 to 7 to 8 to 9 to 10 to 100. Okay, and you'll notice that that original red function starts to get kind of skinnier as we do that. Okay, and so what we're going to do now is you can actually grab the slider here and click it with your mouse and drag it so that you're able to see what happens for certain values of a to the function. And this is really helpful. It just helps you visualize how changing a, h, and k actually changes or transforms the original quadratic. So I'm going to bring this a back to 1 here, and I made a slight mistake here, so bear with me. Usually these go from -10 to 10. So you can change if you'd like to crank this up to like 100, you can do that, or if you want to crank it up to 1,000, and you can crank up the negative number as well. You can go to -1,000 here. And then the step is just how much you want each bump of the slider to change. So you could go from -1,000 to 1,000 with each step being 100. And so what you'll notice is that as you change a and make a very large, it does the same thing. It just makes the parabola skinnier and skinnier. Okay, so let's just go from -10 to 10 here though, and we'll go by once. on the step. So we can bump a to 1, 2, 3, 4, 5, 6, 7, and you can see what happens. If a is 0, notice that it gives like a flat line here. And then if a is negative, something really interesting happens. So watch this. I'm going to move it from a to positive, and now a is negative. So what it's done is it's actually flipped this. It's flipped it over the x-axis here, and now it's opening downward. And as you continue to increase the size of a, it makes it skinnier, just like it did with the positive version. The only difference is that it's flipped upside down. So that's cool. What's helpful is to just play around with h and k. So maybe you can do this on your own computer, assuming you're on a computer. You can actually do it on your smartphone too. And what I want you to do is I want you to play around with h and k and just kind of figure out what happens to the function when you move h and k around. It's fairly easy to see, but it's a good exercise to do on your own. And so basically what I want to do here is show you that if you're able to write a quadratic and get it into vertex form, you can instantly determine the transformations that it has undergone from that basic, y equals x squared function to the more complex function, like this one right here. So we've got f of x is equal to 2x plus 6, the whole quantity there squared. And so what we're going to do is we're going to get this into vertex form. And remember, vertex form, so vertex form is where we've got y is equal to some number times x minus another number squared plus another number. And so we use a, h, and k. That's pretty conventional. And a couple points here. So this doesn't need to be a minus here. But think about this. If we had x minus and then h was negative 2, you would have x minus negative 2, which is really x plus 2. So you can have a plus sign here. You can also have a negative sign here. That's not uncommon, right? So if we had minus 3, then the k value it'd be like the same thing as saying plus negative 3. So that happens. So just keep that in mind. But what I want to do here is just show you a little technique for how to actually get this into vertex form so that we can figure out how it's been transformed from the original y equals x squared. So on this one, what we're going to do is we're just going to take this 2x plus 6 here, and I want to pull an x out of it. For us to get in vertex form, we need to have a single x here. Okay, so right now we have 2x, and so we got to pull that 2 out. And before we do that, what I want you to do is just imagine if we just were dealing with that 2x plus 6, and we're not dealing with this squared here. If we were going to pull a 2 out here, if we were going to divide this expression by 2, then what we would be left with is 2 times x plus 3. And the reason I know that is because if I was going to distribute the 2 to the x and the 3, then I would get 2x plus 6. Be really careful here and make sure that you don't say 2 parentheses x plus 6, because that's not equivalent to 2x plus 6 like that. Okay, so what I'm going to do here, just visually to show you what we're doing here, is we're going to have f of x is equal to, and in parentheses I'm going to have the square here, but what I'm going to write in here in red is what we did. So we pulled that 2 out, and we're left with x plus 3 now. So here, what we've done is we've extracted the 2, we've divided by 2, and we're not quite in vertex form here. And the reason why is because this 2 is actually inside of the parentheses and it's getting squared, but we don't want it to be inside there. So what we're going to do is we're going to actually think about what it means for us to take 2x plus 3 and square it. So if you think about this for a second, if we took 2x plus 3 and we squared that, that would be the same thing as saying 2x plus 3 times 2x plus 3. We're just going to multiply it by itself. If we were going to actually multiply this out, what would we get? I'm saying that the 2 times the 2 would give us 4, and the x plus 3 times the x plus 3 would give us x plus 3 squared in parentheses. So if you think about this, what's going to happen here is we're going to pull that 2 out and square it. Okay, I'm just waiting on the iPad. It's being a little slow right now. All right, so we've got f of x is equal to, when we pull that 2 out to the outside, it's actually 2 squared. So it's going to be 2 squared times x plus, and let's actually do that in white since it's on the outside now. So we'll have 2 squared times, and on the inside we'll still have x plus 3 squared. So these two things are equivalent here. This right here is the exact same thing as this. Now you can simplify it. So you've got f of x is equal to 4 times x plus 3 squared. Okay? This isn't, right here, this is not quite in, it doesn't exactly look like this, although this is in full vertex form. What I do want to do is I want to rewrite this to make it look exactly like this so that we can figure out, hey, what is A, what is H, and what is K? Okay? So we're not really going to change anything per se. We're just going to rewrite it in an equivalent form. So f of x is equal to, the 4 can stay there. X plus 3 is really kind of like x minus negative 3. And then we don't have anything out here for k. So what we can do is we can actually add 0. So effectively what we've done here is we've taken this after we simplified it from here, and now we've rewritten it in complete vertex form, so you can now identify what exactly is going on here. All right, so now we're going to answer the questions of how has the original function, like y equals x squared, been transformed if our new function is like this or like this. That's the same thing. So first of all, the question is, are we going to have a vertical stretch or shrink at all? And hopefully you've played around with the Desmos a little bit and you've realized that if this number here, this a number, is larger than 1, that it stretches the function vertically. Okay? You can also think of it as compressing it horizontally, so it kind of squeezes it in sideways. It's also the same thing as pulling it up vertically. So the new y values are going to be 4 times the original y values, which causes it to stretch vertically. So what we're going to do here, I'm just going to circle, it's got a vertical stretch by a factor of 4. Okay? Is this reflected at all? So if you look at the original y equals x squared function and you compare it with this function, it is not reflected at all. It is still, it still preserves its U shape. Okay? If it was going to be reflected, that happens when the a value is negative. And we would say that it reflects over the x-axis. In this case, that's not true. Okay? Is there a horizontal shift? There is a horizontal shift. This is actually, right here, this number, the h determines the horizontal shift, how much it's moving left or right. Okay? And this might seem a little backwards, but this is actually shifted left 3. And the reason why that is if we are able to write this in x minus h, if we're able to write it in a form like that, this number here tells us whether we moved left or right. So negative 3 means we moved left 3. If this was positive 3, if this was just like x minus 3, then we would have moved right 3. Okay? Is there a vertical shift on this one? There is not. The vertical shift has to do with this number. If you go around and play in Desmos, you'll notice that this k value right here makes the function move up and down. So for a vertical shift, we're going to say none. You could say no. Whatever, same thing. So let's look at another example here. So determine the transformations from f of x equals x squared to g of x is equal to negative 3x plus 5 squared minus 2. So let's do it. So g of x here is going to be equal to negative, and we're going to do the same thing we did last time. I'm going to factor out the 3 here because I need that x to be alone. So I'm going to pull the 3 out, and the question is what's left if we pull that 3 out? So if we have 3x plus 5 and we pull the 3 out, then what would we have left right here? What should I put in that, where that question mark is? And the answer is, well, you're just going to take whatever this number is divided by 3, which doesn't really work out nicely, but that's okay. We can just write 5/3. Okay, so when we factor out a 3, that's what we have left in there. So we'll have x plus 5/3 squared, then minus 2. And what we're going to do is we're going to do the same thing we did last time. So we'll have the negative here. We'll pull that 3 out in front, and we'll keep the x plus 5/3 in there, except when we pull the 3 out, we got to square it, because inside these white parentheses here, that 3 is being squared. So if we pull the 3 out of the parentheses, we just need to take into account the fact that it was squared originally. So this will be minus 2 there. Oh, not in red. Let's do that in white. So minus 2. And so g of x here is going to be negative 9 times x. I'm going to write minus negative 5/3 squared minus 2. And so this puts us fully into vertex form right here. We've got our a value, this is our h value, and this is our k value. And this will let us answer these questions down here much easier. So is it a vertical stretch or shrink? Yep, it's a stretch here. And that's because this number is greater than 1. If this number happens to be between 0 and 1, and you could take the negatives as well. So really, I guess anything between -1 and +1, if you have a number in there other than 0, like 0.5 or -3/4 or 1/3 or -2/3, something like that, you're going to have a vertical shrink. But in this case, we have -9, so 9 is much bigger than 1. So we have a stretch by a factor of 9. We do have a reflection over the x-axis, and we know that because of the negative here. So that takes all the y values and negates them, and so what that does is it flips the entire function upside down. Is there a horizontal shift? There is here. The horizontal shift is going to be right there, so it's going to be left by 5/3, and there will be a vertical shift as well of down 2. So generally, if this is plus something, that means you're going to move up that amount. If it's negative something, you'll move down that amount.